management consultant and TM1 architect for lab services. And in today's webinar, we'll be talking about modular TI processing environments. And we will be introducing modular TI processing, and we're doing that by using the modules, or excuse me, introducing you into the generation of TM1 subsets and views through corresponding TI modules. Before we start, however, just give me a sec here.
Welcome, everyone. Please note that we are recording today's conference. If you have any objections, you may disconnect at this time. Today's conference is scheduled to run for about an hour and a half. Thank you. And Andreas, if you could begin, please.
Good morning, everybody. Good morning again. We'll be talking about modular TI processing environments today. And we'll be introducing you into the concept of modular TI processes by doing that through showing you how to build TI, TM1 subset TI processes and views through a separate modular TI process. So before we start with this, I would like to do a brief, I would like to very briefly revisit last week's seminar where we were talking about introductory guidelines and proven practices for TM1 configuration, model architecture, and design. This was what I call the primer session to this entire webinar series. So in the context of the next few months, we'll be diving into the details of all these subjects that we touched upon just last week. And I would like to just briefly present to you or actually three commentaries, and we got here two items were brought up by Chris Kern from Carpet Datum. Very much appreciated. Thank you, Chris. Chris mentioned that he found that apparently, as of the latest fix spec, supposedly view construct can be used by, or the cache of view construct can be used by TI processes in the data tab. So contrary to what we were saying in last week, where we said you can't use we said that a TI process can't leverage the cache, the VMM configured cache in the data tab. Apparently, as of the very latest hotfix, that's supposed to be possible. So brand new, we will retest and validate if that in fact is the case. Chris hasn't been able to test it yet either. So, and if that is indeed the case, we will update the materials that that it will be possible as of fixpack 6, which is the very latest fixpack of TM1. Just mentioning on that, and this is not a bug, so if this was implemented, this was really just an enhancement. Also, Chris noted that a caveat to keep in mind when using cube clear data, please keep in mind that it will also clear feeders. So if you use cube clear data to clear all the data, and let's say a massive cube, and you're saying that runs faster because the cube is massive and it's faster than view 0 out, you will have to process the feeders for that cube as well, reprocess the feeders. That, of course, means it's more of a trickier trade-off. If the feeder processing takes half an hour, then it might not help you much to use cube clear data. Where I, for example, use cube clear data the most is really with massive cubes that don't have any feeders, where I'm using feederless rules that we talked about that last week. Last but not least, Serena made a very valuable comment. Thank you, Serena. Serena from Lodestar Solutions on a good use case for using separate time dimensions, like separate year and month dimensions. She mentioned that if one wants to use relative proportional spreads through the UI, then it can be very helpful to have a separate year and month dimension, because you can, for example, use the prior year as the base for the current year. You can't currently do that with a continuous time dimension. It's not how relative proportional spread functions. What I will look into is if that is still the case or will still be the case with TM1 10.3, TM1 11, where we will have the hierarchies features that actually allow you to analyze different hierarchies of one and the same dimension on different axes. So theoretically, it shouldn't have to be necessary anymore. Theoretically, we should be able to use relative proportional spread using hierarchies, but I'll find out, and I will update you accordingly. So with that being said, let's go and start. This one here. So we will be introducing methods to build modular TI processes for view and subset creation. The reason why we'll start with view and subset creation is because that's what most of us do a lot when we build TI processes, and we do it repeatedly, and it's, by my opinion, one of the most useful procedures to wrap it to a module. So if you use a module-based approach to TI processes, you typically get the following advantages. You significantly reduce your development time because you just rely on your module. You call the module, you understand the module. You have vastly improved maintainability. Means if you want to make a change to how a TI queries or how a view or subset is created or what is part of the subset, you typically just change the parameters of that module that you're calling. You're not really changing code. You have improved ability to upgrade a model with a new TM1 feature. So you'll see later we'll have a process that creates subsets. We'll have a process that creates views. Now, there's an improvement in TM1 that allows us to build views and subsets in a better way, as there just recently was, and we'll talk about that. You can just embed that into the one TI process that uses that, and you have it immediately available in the entire environment, rather than having to change possibly 50, 60, 70, 80 TI processes, which is a massive change request, a massive effort. You get higher code transparency too. We do a lot of so-called health assessments of TM1 environments that other people have built, and it is much easier to understand what a TI does, what is being built, and what is really queried if code is wrapped into a module, because one just has to understand the module and then see, oh, that's how that is called, that is how that is called, rather than having to look at hundreds and hundreds of possible rows that are used for subset and view creation in each individual TI. Last but not least, by my experience, you typically get a higher stability reliability because there's just less code and you have fewer opportunities to make mistakes. And I'm speaking for myself here. I do make mistakes. I make just sometimes it's typos, sometimes it's just really a mistake. And if I have my module, I know the module works. It's been proven and it's tested, and that allows me to simply write less code and make less mistakes. So examples for these templates, we'll be discussing those in the course of this webinar, and we'll provide you with links to download the example, and including those hands-on exercise instructions, which are really part of this PowerPoint here. Now, before we dive all into this, what we're presenting here is just one way of building those modular TIs. There's no best way, I would argue here. This is one of the proven ways to do it. I was brought, this general approach of building modular TIs was brought to my attention quite a few years back by IBM's Brad Babion, and I'm very thankful for that, and I learned a lot from him on that. And these methods we keep on using these methods and they work for us. There might be other methods that work for you. So the idea of this webinar here is to convey to you how you could do it, that it is useful. If you would like to use those templates here that we're providing, please go ahead. You feel free to do so. There's nothing special about the code in there. It's really more about the method, the idea of using a module to build a subset and build views. Okay. So we will start with a brief review and brief demo of well, actually, I will skip the demo here of TI basics. Just to quickly level set all of us, and and we'll do a brief review of how subsets and views are typically created in TI. And I will skip the demo part here. You can do that using the examples that were provided. And this PowerPoint is relatively long. I will skip through a lot of slides because most of you do understand TM1, but you can use this PowerPoint to let's say, educate or train people very new to TM1. Please feel free to use this for that. We don't have a problem with that. We encourage you to do that. Part 3 is really what we'd like to focus on, is the modular code for creating subsets and views. And we'll show examples for more basic modules and examples for more advanced modules, templates, right? And I will have a short summary. So what is Turbo Integrator? TM1 Turbo Integrator, also most people refer to it as TI, allows us, similar to store procedures in relational database management systems, to create reusable and dynamic procedures to access, administer, process, and manipulate TM1 master data, metadata, fact data, security, and so forth. Well, I said there are dynamic procedures. They don't have to be dynamic, obviously. They should be more or less dynamic, but they don't have to be. So they're called TI, Turbo Integrator Process, or TI Process for short. What are they used for? Typically, master and metadata creation and maintenance, data loading, data processing, data submission, copying, seeding, and so forth. Calculations, process calculations in a queue, as in, let's say you need to do a complex calculation based on actuals, and you don't want to calculate that in a rule, in a real-time rule. Sorry about the noise on the call. Let me see if we can change that.
I took care of that, Andres. Please
okay.
Continue. Thank you.
So how do we build a TI process? We have the wizard-based approach. We're not looking at that in today's session. So you could use the TM1 Architect TI process wizard, rather, let's say, old-fashioned. It's good for simple to average complexity processing. I'd actually say more simple complexity processing. Not good for generic process modules. We have the performance modeler UI, the wizard, good for simple to average complexity processing, but not good either for building generic process modules and modular TI processes. So those of you who work with, let's say, performance modeler, you build TIs with performance modeler. It builds good TIs. The problem, well, it's a matter of opinion. The problem is it will end you up with pretty much one TI for each purpose that you're building, which is perfectly fine for a lot of TM1 environments. If you have very large environments, we tend to like to build more generic TI processes where one process can fulfill the purpose of maybe processing many, many cubes, for example. So we're looking today at modular TI processes that are built manually and that primarily use the TM1 Architect TI Process Advanced tab. So you can also build these processes more, in most cases, using TM1 performance model. You just don't use the wizard, right? So those are good for simple to very complex processing using the advanced tab in the TI process editor. Admittedly, one does require some basic TI process modeling knowledge, and they certainly work for building very generic process modules and modular TI processes. So that's what we'll be focusing on today, the advanced tab, and this is the section that I just want to go through very quickly here. In the parameters tab of the advanced TI tab, we define and set process parameters. The Prolog, metadata, data, and epilogue tabs, they mimic programming loops. Prolog executes its code base once. The code in the metadata tab runs its code once for each record in the data source. Same thing for the data tab. Then the epilogue tab is then run once, similar to the Prolog. So now, we skip through these here. This is really just an exercise in building a basic TI process that loads data. Now, what we often end up with then is we build a TI process the most simple way. We end up with the following quote-unquote problems. First of all, our data source is hard-coded, so if it were to change, the name were to change, the location were to change, we'd have to change that. Second of all, the zero-out view, in this case, in this example, where we're just using a file as a data source, our zero-out view is where we define which data we want to zero out prior to reload, is static, hard-coded, and often, if regular subsets are used, is susceptible to accidental change. So if we make a mistake in accidentally giving people admin access and they overwrite the subset, or we as an admin accidentally override it, then that can be a problem. So what's the first step to ensure that this doesn't happen is to enhance the process by making sure the data source is dynamic and parameterized, and the view is dynamic, and the view and the subsets are built at runtime. So now here are some steps this is really just basic steps how to do that, and most of you are familiar with that, I would think. And this is the section that I would like to skip through. Okay. Now we'll be introducing modular TI code. And for that, I will switch over, excuse me, to Architect in just a minute. What you normally or very typically see in TM1 environments, and I'm just saying that this is typical. I'm not saying that, I'm not presuming that you do it the same way, but it's very typical that there's a lot of code to create views and subsets for each TI that loads or processes data. And the question is, why don't we do this just once by creating a module, a separate TI process, and then just call the TI process when needed? So what we're starting out here, what I'll be presenting is a TI process called createView, and that process will create a view against any specified queue based on the parameters that we're specifying. And createView itself will call a subprocess. It's another TI process called createSubset to create the view subsets as indicated needed. Let's take a look at that. can all see my architect window here. So to revisit this.
I can see it, Andreas.
Thank you. Thanks, Sophia. So this would be a very basic cube load process, right? We're having a CSV data source here. We're defining the cube. We have a view that we set up and that we're zeroing out. This is very basic, right? And here we're doing some processing based on that data, and that's really it. Let's run this, it runs, it's all fine. The problem with this is that it's all really hard-coded, so if anything changes, I'd have to make a change to the process. So what we do is we create the view in the prologue, and we parameterize the data source. And this is, I call this the typical TI process. We see that a lot. So the cube data source is specified as a parameter. You have some process parameters. Let's say this is forecasting planning. So we're just a simple example. We're going by year and by version. So what we do in the prologue, we create our view, and then we create our subset assign that to the view, and this is just some code that the type of code that we see a lot. Then we created the view and the subsets with the view. We do a zero out, and then we can do this earlier, but here we are assigning the file data source to as a data source to this TI process based on the cube that we want to load into. And based on the data source that we want to load. So if this changes here, that is all fine, because what we're doing as a parameter, we're specifying the location and file that we want to use as a data source, and then in the prologue, we're telling TM1 to use that one. Okay, so the same code here, and in the epilogue, what we're doing now, some people call it housekeeping. We created this view here in the prologue for the zero out, and we created those subsets, and in the epilogue, we just destroy it because we don't really need it. We just wanted to create the view for the zero out and the subset, and then destroy it. So now works the same way. All right. Now we have all this code here, and let's say somebody says, I don't want to only filter by version. I also want to filter by cost center. I also want to filter by region. I also want to filter by account. I want to not only filter by one account, but possibly multiple accounts, and so forth. So what we often see is, in a lot of TIs, we see variations of this type of code, and the subset creates section for each individual version tends to be different depending on the requirements of the TI process. So often this ends up being 100 rows, not just this, but this section can be quite long in a lot of cases. And that's a lot of code where one can easily just make a normal mistake, be it a typo or whatever. The other problem is it all has to be maintained. So the idea hence is to use a module. We still need some kind of data source to set up our variables. But what we do here use a subprocess to create our view. We call this subprocess to create the view. Then we do the zero out, and then we call a process to actually destroy that view. We don't even have to do that in the epilogue. We could, but we don't. And then we're done. Now you could say, yeah, that's a few rows too. The good thing about this is this code is completely generic, right? This code, I can, if I wanted to use this TI process to load a different cube, all I do is rename the process. Let's say, right now it has a generic name, but it does load data onto a specific cube. No, it actually doesn't. I changed it here. So if I wanted to, let's say this is a specific process for a specific cube, all I would have to do is rename it and change the cube parameter. If you don't want that parameter for the cube to be a parameter, because end users run it and they're not supposed to run it for every cube, you could just hard code that parameter in the prologue, right? But the idea is all of this is entirely generic. So what makes the process do what it's supposed to do is all defined here in parameters that tell the TI which view to create. So if I say version and I say actuals, I think it was actuals. I think that should work. I have an error here. Didn't test this one. So the idea is that you can create a view here using this process against a specific cube, and then zero out that view, and then do the destroy of the view. So if we call this process here, okay. What I'm going to do here is create a view on that cube, our sample cube that I have here. I'm going to call that cube, that view test 0812, and I say the dimension name. What I want to use as a dimension name, I want to create a filter for cost center, and I want to have n-level descendants of the C-level cost center corporate. Here's my view, right? And sorry, the subset editor popped up on my other screen. Here are all months, for example. And here is my subset for the cost center. That's the subset that was built. So what's the advantage of this module? The advantage is that I can call this module from any TI process, and it always will do what I'm telling it to do. So all I have to make sure, obviously, don't make a typo in how you call the parameters, but you can use this against any cube, right? So the idea here is that you can specify any dimension name that you might want to create a specific filter on. If you do not have the dimension specifically entered here, put a If I didn't use version, it would use the default subset. And default subset in this case would be all n levels, right? You can specify if the view is supposed to include consolidated elements or not, right? That affects the view. I can specify if I want to zero suppress the view, and I tend to always make this typo when I use the word suppress. Can't get it out of my system. And furthermore, what is nice to, you can say include rules, and you can filter by attributes. So I could say, well, I want to have the n-level descendants of the element corporate, but I only want the ones that have, let's say for attribute, manager is supposed to be Steve Jobs, right? What it will do there, it will create an MDX subset that says, give me the n-level descendants of element corporate where manager is Steve Jobs. And it will do that in MDX in this case. So how does this work? Let's look at that process. Create view. So I'm just checking if relevant conditions are given. I need a cube to create the view, okay? What I'm doing here too, I'm saying, well, if there is no view name defined, let's just use a default view name. That is nice because I can just use that view name and I don't have to specify it here, okay? Also what it says, well, if you don't give me a subset name, just make the subset the same name as the view. Makes it easy too. Then create the subsets, and what it does there really is it will go through a loop depending on how many parameters I have. There's a while loop here that will go through all the parameters and then call a subprocess, create subset for that dimension that is used in the parameter. So what it does, in other words, it will loop through, is there a dimension A name, B name, C name specified, and if there is a value here, then it will run the subprocess to create a specific subset. If there is none defined, it will just create a leaf level subset for the dimension of that cube. So what I tend to never really do is use the all subset. I will always create a subset specific to the view. I will not use the all subset. It's just a habit I got into because it allows me to specifically define what I'm really processing. So if we, let's say, if we said we wanted to create a dimension, A, B, C, D, F, G, E dimension, H name, and so forth. So because you say, oh, well, I got 1, 2, 3, 4, 5, 6, 7 filters I can set now. I can filter by 7 dimensions. I want to add another one. All you have to do is add this parameter, the parameters here, okay? And then add the parameter to this string here. What we're doing, we're looping through the parameters, and how we can do that is by using the expand function. If you're not familiar with the expand functions, I am planning on doing a section on that in a few months down the road. Can be an incredibly useful function to dynamically determine which TI parameter to call. It allows you to also save and store the name of a parameter in a TM1 lookup cube to then call the parameter and its values as well in TI. So very helpful for that. So we're calling the subset here, right, after we created the view. Sorry, create the view, we create the subset, and in the epilogue, we create the view based on the parameters provided. This is just, standard TM1 code. You've all seen it. You've all used it. The only difference may be that a lot of people just don't wrap it in a module. How do the subset create processes look like? Create subset. This is the submodule that we're calling to create the subset. What's the dimension? What's the subset name? What's the element name? Attribute, attribute value. So these parameters correspond to, let me bring create view up again. So for dimension A, that name would be passed into dimension name. Dimension A element would be passed to P element name. Attribute, dimension A attribute would be passed to P attribute, and P attribute value would receive the value from P dimension A attribute value, right? And then the subset would say, well, if I do exist, I'm going to, let me destroy. This is the simple way, create view and create subset. So we have some more advanced versions that we'll be talking about in just a few minutes. And here in the epilogue, we'll create the subsets. So if the dimension exists and the subset name is not empty, then it will take a look at the parameters provided. So and this is really just a matter of preferences. I say if I get an asterisk as the element name, or in the element name I provide the just the entry all. Right? In that case, I'm doing a subset as all set. Unless I have an attribute filter in which I have to filter it by the attribute. The other alternative is, okay, I have all descendants as a prefix to the element name. So let's say you have your parameter is, let me do this here, a world for the region dimension. So what that would do, if I had a region dimension here, it would create a subset with all the descendants of world. If I say ND, it would create the n-level descendants of world. So a leaf level subset, and so forth. I'll have, these are just suffix names that, we at some point came up with. This is just one way of doing it. Other people like to have a separate parameter to tell the TI what to do with that element. You could have a separate parameter, let's say P dimension A, subset type or something, and you say n-level descendants. That's just, it's the same idea, right? Doesn't matter, you don't have to use a suffix or prefix. I personally like to use the suffix because it reduces the number of parameters that I have to process. And so far I have not had a problem with those with the suffixes interfering with element names. If you just want to create a subset with a single element, you just enter an element name, right? If you leave it empty, this subset, this TI process will assume it's leaf level descendant. Now, yes, these TIs tend to get relatively complicated, but you only build them once, and then you might make enhancements to them. Again, you can use this if you like, or build your own. There's no right or wrong. The only key is that you want to have a module. The modular approach is also very helpful in that you can add functionality. You can say, oh, there's this new feature that allows me to build only temporary subsets and views that came out in FP4. Great. That means I will have no more locking. But, oh, do I have to implement this now for every TI? No, I can actually implement it for my module. That will take me only a few hours. I will test it, and if it works, I'm good, right? So, keep that in mind. So what I'd like to show you now is how we're doing that. So this is the fancier version of the TI process. What I tend to do is I don't even use a regular file data source. What I'll do is I will deploy an empty, very large cube into my database, and I will use that as my default cube data source. Then I will define variables V1 through sometimes V50. And I will define all of them as other. And then I will use code similar to that for the load processes. And with that, I have a load template that I can use everywhere. Then in the data tab, obviously, you would have to assign the generic variable names to something that is somewhat sensical. There are multiple ways of doing that. This is how I do it, right? So let's quickly go back to the PowerPoint. Let's revisit this. So pcube name is the name of the cube for which you create the view. View name is the view name. Is empty. If empty, it creates a hidden view. Subset name, you can specify the subset name. If you leave it empty, the view name will be used. You can say include rules, yes, no, include C rules, yes, no, zero suppress, yes, no. The good thing about all of these processes, however, keep that in mind, when you build something like that and use it, make sure your defaults are what you commonly use, because keep in mind, yes, these processes might have a dozen or two or three or even more parameters, but you really only have to call the ones that you really want to use. So you don't even have to be so intimately familiar with the ones that you tend to not use often. So the defaults are important, right? Here in the PowerPoint, it is described what those parameters do. Okay, you have dimension a name. You can use dimension 1, dimension 2. It doesn't really matter, right? I tend to do it alphabetically. It does not in relation to the order of dimension in the cube, and you don't have to be, you can use dimension B name could not be populated, and you can populate dimension C name. That works as well, okay? So this next slide shows an example of how you build and apply this. Okay. And it shows how you can build a process to destroy the view, how you can control, how you can call that process. All right, and now I want to talk to the process that I call sys IBM subset create pro, because it's a subset create process that we often use, and we just populate it into new environments. It's not something that comes with IBM software. It's just, it's some very common generic code. And this is also a process that is part of that package that you'll be able to download. This one is a little bit more comprehensive, and I'd like to talk about that. So the first part of the process allows you to define basics of what the subset's supposed to do, the subset create process is supposed to do as in dimension name, subset name. Is it supposed to destroy an existing subset, right? So it's all, this process gets very granular. Do you want to create the subsets through MDX? Well, now I'd say always MDX, but a few years back, that the answer to that have often been MDX and no. Element name, attribute value, very basic, okay? And for element name, all these filter conditions apply that the filter suffixes apply that we talked about before. Then what I tend to do, and this just helps me in for version and time dimension filtering. If I have a forecasting and planning application, by defining what the version dimension is and what the time period dimension is and what the time period dimension type is, and by setting these parameters, I'm actually able to create a view using the subset create process that automatically will only include the last actuals time period, the first non-actuals time period, the first only actuals time periods, only non-actuals time periods, and so forth. I find this very helpful for let's say procedural workflow-related processing in the context of forecasting, budgeting, and planning, because I don't have to think about it anymore. I just say, if I want to, let's say, actualize or freeze the current forecast, I just say use the first non-actuals period. Yes, I don't have to think about and determine the time period, because I know I have an attribute on my version dimension that tells me what month that is, okay? And the process will do that automatically. It's just very, very helpful and convenient, because you don't even have to think about it anymore. So we talked about the time and version management related filtering, and then filter by cube view extract. If you're like me, I hope you're not like me in that case here. I'm not very good at memorizing MDX syntax and how TM1 likes MDX syntax to be written. And so what I tend to do is, build a generator for that MDX into the TI processes and leverage that. That also allows me to refresh my memory better. And in the context of quite a few projects, we found that in order to get better performance, it's not quite a few, in the context of a few projects, we needed to build zero suppressed subsets. Subsets, in other words, that were filtered by a view extract. An example is if you run allocations, and in a lot of allocation cases, you can't really work around looping through a subset in the data tab. Well, let's say you want to process 50,000 records. You want to allocate 50,000 records, and each of those 50,000 records should be spread. These are all, let's say, R&D costs that are not assigned to products, and you need to allocate those to products. And you're talking about a large consumer goods company, for example, where the products that you're allocating to are in the area of 20, 30,000. Now that's really a big task to process. And what you want to do is when, let's say you want to allocate that data based on percent of sales. Well, that means for a given allocation instruction, you want to make sure that you're only allocating to the products that have sales for that corresponding R&D cost line item. Let's say that's the region, United States, or for a particular month, right? You don't want to always allocate to, or you don't want to include all products into the loop if only 10% of the products have sales data. So that's where this becomes very important. And this is a module that allows you to specify a cube here and then specify dimension and element names. This is all leaf level based. And provide a string filter value if needed to. It's not, it doesn't provide you all the functionality of filter by cube view extract, but you could certainly enhance it. So here's the documentation, if you will, on what those parameters do. Now, the very latest edition of this subset create process, and that's also part of the package you got, also has a parameter for temporary versus permanent subsets. As of FP4, TM1 allows you to create temporary subsets, and there's no locking associated with those. The problem with this functionality is, unfortunately, one couldn't use these temporary subsets and temporary views in a TI process. So that one could say that was quite an unfortunate bug, because the functionality that we wanted it for wasn't available. As of FP6, that's supposedly fixed. I have not yet been able to test it, but I will update you on that. But it is already part of the code for this module. Now we go to sysIBM view create. That leverages the sysIBM subset create module, right? And the idea is the same. We're creating the view. We need the cube, the view options. Do you want to create the subset as MDX? Then it has those parameters that allow you to specify only only include a specific time period. It does that automatically based on the attribute on the version dimension. In here, you can also tell it if we have a separate month and year dimension, or if we have a time period dimension that is continuous. And then it's the subset parameters that we talked about earlier. And again, here it also has the parameter P temporary versus permanent views. Okay. I did test if this works and create the views, and it seems to, but again, I have not, on the test environment, I did not yet install FP6, so you couldn't use it. You could create the temporary object, but you couldn't use it. I'll update you on if that works with Fixpack 6, but it's in there. So before we go to key takeaways, take a look at the code. It's not really code. There we go. View creates. So here are all my parameters. The very bottom, it's temporary versus permanent views. So the first thing we're doing in this, in a fancier version of a view creation module, is we're finding out what the client ID is. What I used to do, I would use TM1 user for that. That was quite useful until I found, well, there were a few roadblocks. First one was when you created a chore user includes the chore name, and it includes the asterisk sign. And what I tend to do is just a habit of mine when a user creates a view, a temporary view, a subset, I always include that username into the subset and view name. It makes troubleshooting a little easier if you have issues with contention or things aren't getting cleaned up. You can take a look at, you know who created that and when, because it's a timestamp and a user. Not that it's the user's fault, but you can troubleshoot better and figure out who ran what when and what wasn't cleaned up. So that we needed to parse out the asterisk because that is not a valid parameter in a subset name. But you would also run into issues if you're using CAM authentication, because the CAM IDs can include slashes, backslashes, and so forth. So what we have is this is a subprocess, right, that takes the TM1 username and parses out the relevant information and comes out with a global variable that we call TM1 client ID. And that TM1 client ID is what we use as the name for our view. So I have a prefix for views that you can define. And if the view name is not specified as a parameter, we're saying use that prefix and use the TM1 client ID. If the subset is not defined, make the subset the same name as the view. Then we'll create the subset. Now the first section here is a little more tricky. The first section here in the prologue will actually determine the subsets in case we're doing this time period filtering. And then, sorry. And then we're looking at what are we doing for all other dimensions. And this is the same type of while loop that I showed you in the prior example. What I have in here, I have detailed logging. That's really why we have so many rows. It allows you have logging enabled here to actually log what instructions you're sending out to the subset create process. Normally, I don't keep logging on for this process, but that's why we have a little more code in here. Okay. I encourage you for this type of code to look at what we're doing here with how we're actually looping through the parameters. I find that quite useful. So in other words, if you add many filters, many dimension filters here, we could go to dimension X name or dimension Z name, dimension Z element, attribute, and attribute value, but we wouldn't really have to add code here. All we'd have to do is extend the length of this string. And it will do that automatically for us. Quite useful. In view create, the only difference to the less fancy module is here if we're creating a temporary view, then make it a temporary view. Keep in mind when you use this approach in a module, if you create a permanent view, you can't really create a permanent view with temporary subsets. So if you're view is temporary, yes, your subset could be permanent, but not the other way around, right? So this is taken care of here too. If the view is to be permanent and the parameter for subsets is says temporary, it will ignore that and make the subset permanent too. Taking a look at the subset create. Before we create the subset, because we're looking at this time dimension filtering, it has to actually retrieve a few values and find out what is our last actuals period, what's our first non-actuals period, and so forth. It needs to do that because otherwise it can't later on build the subset properly. But it will only do that if we're actually telling it that we want one of those subsets to be created. And here is the epilogue. The same parameters, all descendants, n-level descendants, immediate children, C-level descendants, right? These are just really abbreviations of, how we address elements in a tree in TM1. N-level descendants, immediate children, C-level descendants, and so forth. You can also tell it that you want multiple elements, arbitrary number of elements. You just put multi in front of the element name, and then you just separate the elements by a semicolon. Again, these are just, you could use anything as a prefix, whatever works best for you. Just make sure you're consistent and you don't change the prefixes in the course of a project. So if you start with, let's say you don't like ND, and you make that LD for leaf level, or you want to make it leaf, whatever, make sure that you stick with that. So what we have here, the first part of this subset create process takes a look at filter by view extract. So you see here, I only do that if I'm looking at n-level descendants. This process is not the magic MDX generator. It creates only a limited number and types of MDX, right? So what it checks on is, am I looking at leaf-level descendants operations? Am I filtering by cube? Does the cube exist? And is the MDX flag still yes? Because we need MDX for that. So then it takes a look at which dimension elements are actually specified here, and it builds this MDX. I'm not sure if this is the best algorithm to actually build this MDX. I'm sure there are better ones. This one works. But if you have better suggestions on doing that, please let me know. What's important when you do this type of, what I find important when building MDX like that, dynamically in a module, is to always have proper logging. Because if you're like me, you'll make mistakes in how you form this here. Not only 1, but 2 and 3. And you want to be able to, when you build that TI, easily troubleshoot what the MDX was that you created. So here it does a log. If I turn on logging and it tells me the MDX expression, that's obviously something I can easily test in the subset editor, right? So I use that. I don't keep that logging on as I'm using this client typically, but while I'm developing or enhancing this, I use that a lot, right? And then we create the subset, again as temporary or permanent. This here is the same code, but we're not going by leaf level descendants. We're saying, give me all elements, but filter by view extract. very similar, but the MDX is slightly different, right? And then it's what we already talked about. If you want to have all elements, we're doing subset is all set. You want all descendants, you're using the entire branch. Again, there are different ways of writing the MDX and so forth. So again, yeah, it takes a while to build those, but I highly recommend you use them. Not saying if you want to, you can use those. These modules here are build your own. If you say, oh, I have some different ideas, I want to build your own, I tell you it's worth it. You might spend a day or two building the module, but you'll be grateful reusing it and reusing it and reusing it wherever you go. And when there's a new feature, you'll say, oh, let me just embed it into my existing module, and it will work. You can also, by following that approach, let's say you have a customer, let's say you did all you could to avoid locking. You are on one of the latest TM1 hotfixes at a customer, but there's still some locking that occurs when subsets and views are created at that specific customer, and it's really been an aggravation. Now, if you had built, let's say that customer has 100 TI processes to load data, that would be a huge effort to say to the customer, here, implement FP6, and then we'll be spending all this time upgrading. Yes, I do understand there's consulting revenue involved, but at the same time, these are new feature functions that shouldn't take weeks to implement. It's a much different and higher value proposition to say, here, we're coming on site, we're doing a POC with you, or maybe you're just spending a few days on site putting the new functionality in place in the module, testing it out, and everybody's happy. So. So the key takeaways is I highly recommend use Modular TI process design for frequently used TI process tasks. What we talked about today was creating views and subsets. We use a lot of generic TIs for analyzing dimensions, hierarchies, exporting cube data, importing cube data, version management, maintaining a time dimension, and so forth. And those examples, those templates that we use, we will be sharing with you in the subsequent webinars. Today's was just the beginning, and I started with views and subsets, right? Keep in mind, don't call the TI process in the metadata or data tab a subprocess. Do not do that, because it really creates a process handled per source record, and the performance will deteriorate significantly. So whatever I said today applies to modules being called in the prologue or epilogue. Do not call them in the data tab or data tab. It might be tempting at times, but it's not a good idea because of the overhead that the TI process handle will create. Yeah, and keep in mind, a module that you reuse everywhere will only have to be maintained once. So it tends to allow us to focus more on the business need at hand rather than focus on some, let's say, technical basics of TM1, technical basics that we might say, could even be part of the product, but aren't. So with that, I would like to, I will open it up to questions. Just a comment, there are other modules out there. Some of you might be using Bedrock code. That's very good too. So what you see here, we're not saying this is the best way to do it. This is a proven way it's been successful for us. And we just wanted to share that with you. Yeah, so with that, I'll just open it to questions.
Again, everyone, if you have a question, please feel free to post it via the chat box. Andreas, we've had some good discussion in the chat box, and JP's been super in answering questions as well. If you have a question, please feel free to post it via the chat box at this time. Andreas, you must have done a fabulous job in explaining everything because it doesn't appear anyone has any questions. We did have some suggestions via the chat box if you wanted to take a look. Here we have one for, I think, let's see, Tobias has a question. Couldn't it be better to support some list or even array functionality instead of so much parameters?
I would agree, but then for the time being, we don't do that. We don't have that capability in TI yet. But yes, that would be nice.
And Tobias has suggested by JP, maybe you could submit that as an enhancement via the IBM support website. It would probably get a lot of value being from a business partner or coming from a business partner. As opposed to us submitting that. So if you could do that, we would really appreciate it. And if anyone else has a question, please, if you could post it via the chat box, that would be great. Okay, as I show that there are no questions, once again, I'd like to thank all of you for taking the time to attend today. We really appreciate your time and attention. Andreas, thank you so much for a super webinar and demo. And JP, thank you so much for assisting with the chat box. I really appreciated it. Wishing all of you a good day today. Take care, and we'll see you on September 9th, which is our next session. Thank you so much, everyone. Goodbye.
Thanks a lot. Bye.